Hello everyone, we're going to see an intro to FastAPI. FastAPI is a Python framework for building web APIs. It's high performance, easy to learn, fast to code, and ready for production. First, who am I? I'm Sebastián Ramirez. I'm a software developer at Explosion in Berlin, Germany. I'm actually from Colombia, that's why the accent. And you can find me on GitHub, LinkedIn, and Twitter. I'm currently working for Explosion. Explosion are the creators of SpaCy, the natural language processing package for doing things like machine learning over text, and Prodigy, the package for doing data annotation for machine learning using active learning. And Think, the framework for doing deep learning with ideas from functional programming and Python type annotations. I created FastAPI, and Typer we are going to talk about FastAPI. So a little bit about FastAPI. FastAPI has around 16,000 GitHub stars. It's been growing about 1,000 stars per month, so people have been liking it. It's currently used by Microsoft, Uber, Netflix, and a bunch of other people. The performance is in the top rank for Python, so that's quite nice. And FastAPI is based on standards like OpenAPI, JSON Schema, and OAuth 2. OpenAPI was previously known as Swagger 2, then it was renamed as OpenAPI and is now under the Linux Foundation. JSON Schema is used to declare what are the data shapes of JSON payloads, and OAuth 2 is for doing authentication and authorization. OAuth 2 is actually a bunch of standards. And this is what is used by applications that do, for example, login with a third-party application. Like when you do authenticate with Facebook or with Twitter or using GitHub or things like that. All that actually uses OAuth 2 underneath. And because FastAPI is built around these standards, then you can get automatic API documentation for free. So when you create an application with FastAPI, you get a user interface for your API like this one for free. This is actually provided by Swagger UI, which uses the OpenAPI declaration. So you get the benefits of like the interoperability that provides something that is based on standards. So when you create an application with FastAPI, you get something that is based on standards for free. Cool. FastAPI is based on Python type hints or type annotations. Like this, here we're saying that name is a string and price is a float. This is a standard Python type annotations and type syntax. We are going to see an example like this a little bit later. But the thing is that the type hints are what provides auto-completion everywhere in your code. And it's also what powers type checks and type errors in your code, in your editor. So you get auto-completion everywhere in your code, and you can make this little happy face. FastAPI is easy and short, so this is a completely valid FastAPI application. From FastAPI, we import the FastAPI class, and we create an object of this class. We're calling it app, and then we use this app with a decorator that goes on top of other functions. And in the decorator, we declare what is the path that will be handled by this function, and we say what is the HTTP operation or HTTP method that is going to receive. In this case, is an HTTP GET. Then we declare the function that is going to handle this request. This function can be an async function, and then we can use like all the ideas from async and await. But if you don't want to, or you don't know exactly how to do that, or you need to use a library that is not compatible with async, then you can use normal function definitions with def, and FastAPI will run them on a thread pool to not block the main event loop. The thing is, if you know how to use these async tools, then you can use them and get like the extra performance and power from them. Otherwise, you can just use normal function definitions and everything will work as you would expect it. Here we're just returning a simple dictionary, and FastAPI will go ahead and convert this to a JSON response for us by default. We don't have to create a specific class or something. This just converts it to a dictionary by default. And so it's very simple, very easy, and very small the amount of code that we have to write. So the more FastAPI code you write, the less API code you end up writing, because most of your code will end up being related to your actual own application and to your actual own business logic. The code for FastAPI will get out of the way and will be like very minimal. Let's now create a basic FastAPI app. So this one is just the same we had before. Now we are using a normal function definition. We are not using async def, we are using normal def. And we are creating another one here below. This is going to handle requests that go to /items/ and then in these curly braces we have this item ID. This item ID is going to be a path parameter. And this is going to handle HTTP GET requests. So it's an HTTP GET operation. Then this item ID that we declare in the curly braces, which is the same format used for F strings, so it's easy to remember. This item ID, we're also declaring it inside of the function, and we are saying that the type is an integer inside of the function. Then FastAPI will use this type annotation to also convert the data and make sure that we actually receive an integer in this parameter. So inside of this code, the item ID will actually be an integer. And this item ID, if we go to the URL, we will see it will be a URL like this one. We will go to /items/5. This 5 that is part of the URL, this 5 is actually naturally a string because the URL is a string. But FastAPI will take care of converting it to an integer so that we get what we declared. We get the type that we declared. We will get an integer here. Then we're also declaring this Q, which is a string that by default is none. This Q is not part of the path, so FastAPI will know that it has to read it from the query parameters. So it goes here. After the question mark, we have Q equals some query, and this value some query will be the value of this parameter Q here. And then from this simple code that we have here, if we go to /docs, we will get an automatic user interface for the API that documents the API live from the code that we wrote. So we get the /items/, we get the item ID, which is a path parameter, is declared here, it's also declared here. It's an item ID, it's required, it's an integer, it has to be an integer, and it goes in the path. And we have the Q, which is a query parameter, which has to be a string. So you get all this for free. So you write some basic code, and good guy FastAPI goes ahead and makes a docs user interface for you. Now let's write a basic FastAPI app with a body. We're going to receive a request with a body. So let's go down here. We declare this one we're going to declare it as a post HTTP operation. This is not going to be a get, but a post because we want to receive a body. So we say here it's a post and it goes to /food/. And the same way as before, we declare a parameter and we declare the type as this class food. So this is the standard way in Python to say that this food should be an instance of this class food. And this class food is created here above. Let's see how we create that. This class food inherits from base model. Base model is actually from Pydantic. FastAPI is based on top of Pydantic and Starlet. Those are the two building blocks. And FastAPI uses Pydantic everywhere internally. So we are creating this class, base model. We are saying that name is a string. It doesn't have a default value, so this is required. And ingredients is a list of strings. This list comes from typing. And typing is a standard Python module. So this comes with Python by default. So this is the standard way that you use to declare that something is a string, something is a list of strings. And we are saying that by default, this ingredients is an empty list. This means that ingredients is not going to be a required value because it has a default. And if you notice, this is actually very similar to how you use data classes in modern Python. It's just that Pydantic and these Pydantic models are going to provide us a little extra features. And FastAPI will take care of making sure that this food parameter here is actually an instance of this food class. So we can access food.name, and we can get, for example, we can get completion for this .name here, and use it internally. And then if we go to the docs, we can see that now we have this post HTTP operation here that goes to /food/, and then we have the example of the body that we are expecting, which should be a JSON object with a name string, and ingredients should be a JSON array with strings. In Python terms, this will be a dictionary, and this will be a list of strings. And the documentation already has an example made automatically for us from that Pydantic model. And if we click here and try it out, then we're going to see this outdated user interface that lets us interact directly with the API. So we can send a request, we can execute it, it's going to go and send it to the live server that we are running, and we're going to receive the message directly from the server with our code live. In this case, we are sending a food JSON body, which has a name of taco. This is a string, and the ingredients is effectively a list of strings, or a JSON array of strings that has frijoles, carne, taco shell, and sabrosura. Nice. So this is all strings. And then we receive the message directly from our application. And this is the face that your API makes when you send a request body full of tacos. Cool. Now let's say that we want to have an application that receives a body and a query parameter. We do the same thing. We declare the parameter food of type food, and then we declare the extra parameter delivery. This is going to be a boolean that by default is false, because this is not part of the path, and this is a simple data type. This is not a class like this one over here. This is just a boolean. It could be a boolean, a string, an integer, something like that. And FastAPI will know that it has to read it from the query parameters. And then if we go to the documentation, we're going to see that we have the delivery, which is a boolean and comes from the query. And because the user interface knows that it is a boolean, it's going to show us the only two possible values, true and false. This is how we will use it in the URL. It will go after the question mark. We will have delivery equals true. And if you notice, this delivery equals true, this true here as part of the URL is actually a string. This will be sent as a string, but FastAPI will take care of, and actually through Pydantic, reading this true and converting it to an actual boolean, so that our code will receive an actual boolean. So you don't have to put everything in the body. You can put parameters in the query if that makes sense and if that works. Now let's say that you want to have a JSON array of JSON objects in the body. So in Python terms, this will be a JSON. In Python terms, this will be a list of dictionaries, let's say. To do that, we just do the same. We have the same Python, the same Pydantic model food. And now we're going to say that we're going to receive an orders, which is a list of instances of this food. So again, we're using the same list that comes from the standard Python from typing. And we are declaring that this orders is going to be a list of food items. So this is like the standard way that you will say that orders is a list of food instances. And FastAPI will make sure that we actually receive what we declared here. Then we can iterate for each food item in these orders, and then we can iterate for each ingredient in the ingredients in that specific food. So you can see like this is already difficult to even say. We have two nested for loops, but this is all declared with standard Python type annotations, and we are able just to use standard Python type annotations for very complex data structures that we might need. And if we go to the docs, we're going to see that it's reflected there, and we can see that it's going to receive a JSON array, or the equivalent of a Python list, with the same objects that we declared that we were going to receive. So FastAPI is not only doing data conversion so that we get the data types that we declared, it's also doing documentation automatically for us from the same standard Python type annotations. So if we want to have JSON objects, JSON arrays or something, and if we want to have them inside of other JSON objects, like any deeply nested data structure that we want to have, we can declare it easily with standard Python type annotations, and FastAPI will be able to handle it with those declarations as we saw. Now, what happens if we send invalid data? So let's see if you can spot what are the errors, what is the invalid data in this JSON request. Like this JSON is actually, this is valid JSON. The JSON is valid, but the data doesn't conform to what we declared that we wanted to receive. If we execute this request with this JSON payload, then we're going to receive an error automatically. So we're going to see that there's an error and the data is not valid, but not just that, we're going to receive exactly where the error is located. So let's see, we have two errors. This is the first one. We're going to see this first error. So it's in the body, and it's at in orders at index 2. Let's see, where is that index 2? So this is the body. This is index 0. And the index 0 is actually valid. Index 0 has a name, which is a string that's valid. It has an ingredient, which is a list of the strings. This is valid. This is what we declared. This is index 0, that's valid. Index 1 has a name, which is a string, that's valid. This one doesn't have ingredients, but we declared that ingredients had a default value of an empty list, so ingredients is not required. So this index 1 is also valid. Then index 2, let's see. In index 2 is where we have the error. Let's go forward to the error. So we have the errors in index 2. Where is the error? It's inside of ingredients in index 1. Let's go back to the request. So in index 2, inside of ingredients, this is index 0, is a string, that's fine. In index 1, exactly here is the error. And what is the error? The error is telling us that a string type was expected. And if we see, again, the data that we are sending the name, which is a string, that's fine. But the ingredients is expecting a list of strings. The first one, index 0, is a string, that's fine. But index 1 is indeed not a string. So we get the error here. We're not only receiving an error saying like, hey, your data is invalid, we're receiving a declaration telling us exactly where in the payload the data is invalid. Cool. Let's now see the second error. We see that it's also in the body at index 3, and the name is a field required. So if we go back to the data we're sending, this is index 3, and we are not sending name. Name is a required field, and we're not sending name. We're sending this strange food name thing. So we are missing that required field. And if we go back to the code, let's go back to the code. This is over here. This is saving us a bunch of lines of code here, doing all the data validation and doing not just validating the data, but also generating the error that tells us exactly where the problem is. This is saving us, I don't know, 20, 50 lines of code here. So you can be sure that your code in here is going to run only with valid data. By the time your code runs here, data will be already validated and the request will be already valid. So you can be sure that you can just add your code assuming that you have valid data, because FastAPI will do all the validation for you. Let's go forward to the error. Here we are. Cool. So if you send invalid data, someone sends invalid data, then your API is going to make this face and it's going to say no. And it's not going to let it pass, and it's going to keep your code safe from running with invalid data. Now, I have been talking about this auto-completion stuff. Let's see how that works. So here, we are declaring this complex data shape, which is a list of food instances, which is this class we declared that has an ingredients, which is a list of strings. And then we're iterating in all this in a double nested for loop. And despite all this deeply nested data structure, we are being able to have a auto-completion for each ingredient, and the editor is going to know that each ingredient is actually a string, and we're going to get completion for a string because the editor knows that it is a string. This is because we are using standard Python type annotations like this one and like these ones over here. This is actually difficult to achieve with many other frameworks and tools because they are not using the standard type annotations for the language itself. And many other tools that use some type of annotations or even standard type annotations might not be able to handle these very deeply nested data structures. So this is quite nice, and it's all based on this standard Python type annotations. We also get type checks. So because the editor is going to know that ingredient, which is inside of this deeply nested for loop, double nested for loop, ingredient is a string. So you cannot sum a string and an integer. It's going to show you an error right there in the code as you are typing it. You won't have to wait to run the code to be able to see that there was an error. You will see the error right there as you type it. So this is going to save you a lot of time. And this is all based on standard Python types and type annotations. So you are getting data validation, data serialization or conversion, data documentation, and also auto-completion and type checks, all for free or for the same standard Python type annotations. Now let's say that we want to add some metadata to the application. We have this delivery query parameter that is a Boolean that by default was false. But now we want to have an extra description. We want to say that we want to pack for delivery. So to do that, we import from FastAPI, we import this query thing, and then we say that the default value of delivery before the default value was false. But now it's going to be this query special function over here. And then this query can receive this extra metadata, this description, and because now we are taking the place that was used for the default value, then this query is going to receive as the first parameter that default value. So this false here is the default value of the delivery query parameter. And if we go to the documentation, we're going to see that we still have the delivery, it's still a Boolean, it's in the query, and it still has the default value of false. But now we also have the extra documentation, the extra metadata of pack for delivery. So you no longer have to keep writing documentation outside of the code. You don't have to keep like a wiki explaining how the API works, or a shared document that gets obsolete very quickly and fight with other teams that are complaining that your API is not working correctly because you updated it, because everything is going to be up to date and in sync automatically from your code. Now let's say that we want to have a required query parameter. Here we just declare it. Quantity, which is an integer, quantity is not in the path, so by default it's going to be a query parameter. And we don't declare any default value. If we don't declare any default value, then FastAPI will know that this is a required query parameter. If we go to the documentation, we're going to see that quantity is an integer that should go in the query and is required. And if we try to execute this request without providing a quantity, we're going to get an error automatically. So this is the face that your API is going to make when you omit required data. So you have to provide the data that you declared that was required. Otherwise, you're going to get this angry face. Cool. What happens if you send valid data? So if we pass the integer here, quantity 2, and we send it, this is how this will look like in the URL. So after the question mark, we have quantity equals 2. And if we pass that, then we will receive the response. Everything will work correctly because we are passing the required query parameters. So we will receive that. Something to have in mind, one does not simply make all query parameters required. So query parameters are normally not required, and it's going to confuse your clients if you make a lot of query parameters required. So it's not a common thing to do, but if you need to, you can do that. Let's say now that we want to add extra validation to that quantity query parameter. So yeah, we have quantity was required and it had to be an integer. But -5 is still an integer. So we want to make sure that it's greater than 0 and is less than or equal to 10. So we want to receive a quantity that is greater than 0 and less than or equal to 10. To do that, we just use the same query that we were using for this other query parameter delivery, and we pass the extra validation parameters here. But now, because we are using the place, this default, quote-unquote default value for the function, we are using this query thing, then now the lack of a default value is what FastAPI was using to know that this quantity was a required query parameter. So now, to be able to tell FastAPI that this quantity is still required, The first parameter, that will be the equivalent of the default value, is going to be these 3 dots. These 3 dots is a valid Python symbol. This is called ellipsis. And this is the way we use to tell FastAPI, hey, this is still required. This doesn't have a default value, this is required, and we also have the extra validation data. And if we go to the documentation, we're going to see that quantity is still required. It's an integer and goes in the query. And if we send what now is invalid data, for example, -5, which is an integer, but is not greater than 0, then we're going to receive one of those nice errors that we talked about before. So if you send invalid data, without valid data, your API is going to make this face, it's going to bark at the request, and it's not going to like it. But if you send valid data, it's going to be all happy and everything will work smoothly. So it's going to do the right thing and keep you safe from invalid data, and then be very happy with valid data. Now let's talk about performance. FastAPI is in the top rank for Python frameworks. This is a benchmark run by Tech Empower, which is a third party. They run benchmarks for many languages and many frameworks. Here we're comparing Python with Golang. The green lines are Golang, the blue lines are Python. Golang is a compiled language. Python is an interpreted language. So this is not a fair comparison. Golang is, of course, going to have to be a lot faster than Python. Otherwise, there will be something very wrong for it to be a compiled language. Nevertheless, you can see that FastAPI and a bunch of others here are able to be even faster than some of the Golang frameworks. So this is quite good performance, and you get to use all the nice things of Python. Now, which one specifically of this is the fastest? It's not necessarily that relevant. You can see that they are more or less on the same ballpark. In fact, Uvicorn, which here appears to be below FastAPI, should be on top of everything, because Uvicorn is not even a framework. This is the server itself that runs the application. So this has to be faster than any of these things. But this has some random noise included. And FastAPI is built on top of Starlet. So that's why FastAPI is so fast. It's all because of Starlet. But yeah, you get the idea is that you get on the top rank performance for Python frameworks. You can see Flask is over here below, and Django will be somewhere down there. And as you can see, we are being able to handle 15-something thousand requests per second in this benchmark. So that will mean that it's over 9,000 requests. So that's quite nice. Now, FastAPI has other features. There's a powerful but simple dependency injection system that you can use to, for example, do authorization and authentication of users, get the current user based on the token or on some sessions from query parameters, things like that. You can also do database session management with the same dependency injection system, and this is all going to be integrated into the same OpenAPI that is generated automatically. So everything is going to be documented automatically, even when you use the dependency injection system. That's what it is there for. There's also a bunch of security utilities based on OAuth 2, so you can build tools like those that we were talking about, where you can log in with Facebook or log in with GitHub, or allow this application to have all these permissions and so on. So this is all possible, and it's all integrated, and there are tools to build these things integrated with FastAPI. Also, because FastAPI is underneath actually an asynchronous framework, then you get support for WebSockets if you need that. There's also, you can do files, receive or send files. There are lightweight background tasks, easy GraphQL integration, and more stuff. For example, Jinja templates and a bunch of other things. Now, when not to use FastAPI. So if you already have, let's say, a stable Django application or Flask or any other framework, it's already stable, you don't need any new features, and it's not an API, then you probably wouldn't get a lot of benefit from FastAPI. You wouldn't get like a lot of advantages or benefits from FastAPI. But what you can do is, if you already have an application, you can add some lightweight layers of FastAPI on top, for example, for new features or for the new versions of the API, for receiving new data or for new endpoints that you are deploying. And they can coexist, and they can even use the same database. FastAPI is not compromised with any database, so you can use any database that you're already using. You can use the ORM that you're already using, most probably as well, and like the same tools and the same things. There's still a bunch of things that have migrated their applications completely to FastAPI, and they have been happy about it. But just so you know, it's not necessarily the best idea to just go on FastAPI for all the cases. Other tools that you might like, if you like these type annotations, Typer is a tool for building command line applications, also based on type annotations. It's very much like FastAPI, but for the command line. You get auto-completion and type checks and everything in your code, and your users are going to get shell completion in all the shells by default when you create an application with Typer. Think is built by Explosion, the company I work for. It's a functional deep learning framework with types that is compatible with your favorite libraries. So it's compatible with PyTorch, TensorFlow, etc. That's what I have for you. Thank you very much for assisting. You can go to the docs here at fastapi.tiago.com. If you have questions and we haven't answered them, then we can check them. You can also check the documentation. There's a lot of information in the documentation. Otherwise, you can also check the GitHub repository if you have questions later. Then you can add them also to the GitHub repository for FastAPI. I hope you have fun with FastAPI. Thanks for having me.